So my name is Dr. Crystal Collier. I am in Houston, Texas. I'm a therapist and a prevention researcher. I have been working in the field with teens my entire career, but what I think really qualifies me is that I'm also a person in long-term recovery and am recovering still sometimes from the risky behavior that I engaged in when I was a kiddo. So these are the pictures of me as I was growing up. I didn't have a lot of family stability. And so by the time I was 11 years old, my parents, my mother and stepfather were getting a divorce, and we moved to the big city, Houston. And I was just terrified about starting a new school in such a large population. And so my mom took me to register for classes, and I remember seeing this sign that said summer school. And I thought, oh gosh, I really want to take summer school because then I will be able to meet lots of new people before the school year even starts. And my mother agreed to this. And I met a lot of really great kids who were making a lot of really bad decisions. And I ended up taking my first drink by the time I was 12 years old, just a couple weeks shy of my 13th birthday. By the time I was 16, I had tried everything under the sun, intravenous substance user. Always, though, a straight A student in school. We moved almost every year. So I took a lot of summer school, graduated a year early from high school, went straight into college and graduated to bigger and better risky behavior. And then by the time I was 18, I had a pretty bad overdose and thank God survived it. And that last big Texas hair picture of me was taken the day that I graduated from rehab. So my sobriety date is February 3rd, 1989. And when I got into recovery at 18 years old, I was really terrified about relapsing because I'd had an overdose. And I was also really confused about why I had made all these terrible decisions. So that is when I started reading everything I could get my hands on about addiction to really help me understand it and explain it. And so it was a cool time to go to school because all these brain studies, as you see above my pictures there, were being published. Back in the 90s, it was kind of the decade of the brain. So I started collecting information as I went along. And so what we're going to do today is go over what I think are the 5 critical skills that everybody should know to understand how the brain gets trapped by addiction, and addiction of any kind, whether that be a behavioral, a substance, whatever that looks like. So we're going to go over 5 different areas today. And like Tyler said, please feel free to unmute yourself and jump in or put your question in the chat. Tyler will monitor that for me and be able to jump in at any time. So here's what we're going to review. We're first going to talk about brain development because we need to understand how the science of high-risk behavior affects brain development. Then we're going to talk about literally how the limbic system gets hooked and trapped by addiction. Then we're going to do a little bit deeper dive into genetics and the effects of dopamine. And then on top of that, the second area of the brain that is affected by high-risk behavior is the frontal lobe. And then, of course, we'll talk about relapse prevention after that. So again, please remember you can jump in with a question at any time. Okay, let's get started. So the first thing that we really need to understand, especially if we're going to teach this to kids or if we work with clients or coalitions, is how high-risk behavior affect brain development. So one of my favorite researchers, Dr. Lawrence Steinberg, he has my favorite quote, really, is that an adolescent has a well-developed accelerator, but a partly developed brake. And so this is a picture, a graphic picture of what he looks like, and with the superhero of my children's book series, Know Your Neuro Adventures of a Growing Brain. And I love that the brain is literally learning about the brain. And so in order to really get this, we have to just make sure that we know two different parts of the brain, and this is how we could teach it to kids. The accelerator and the brake, such a great way for kids to learn how to do this. I've got parents that I work with that say to their kids, okay, slow your accelerator down, use your brakes when they want to help them learn impulse control. It's a great technique to do that. So if we think about the part of the brain that is the accelerator, most people know that it is the limbic system. These little teeny tiny little organelles that are located deep inside of our brain, sitting almost in the back, right above the spinal cord. This, of course, is our fight or flight, freeze, fawn part of the brain that assesses threats and helps us figure out what we need to do to survive. But what most people don't know is that it is fully mature by the time we hit puberty. Which, if you think about it, makes a whole lot of sense because once we hit puberty and we have the ability to procreate, we really need to protect ourselves in new and different ways. But the limbic system also serves another really important role for kids. It impels us out into our environment to seek novelty, to seek out new things, so that we can individuate, break away from our family of origin, try on lots of new things, and figure out who am I as an adult. The limbic system coming online right around puberty helps us do that. This is why kids shift so much during puberty is they start to become argumentative and emotional. And for many decades, we have just attributed that to raging hormones. And although we do have an upsurge of hormones in our body, our brain is really responsible for a lot of this moodiness, irritability, argumentativeness, aggressiveness, but also curiosity and energy, and the ability to go out and intrinsically seek out different things. This is our beautiful accelerator, fully matured by the time we are 12. But our brakes, as you guys know, the prefrontal cortex or the frontal lobes, the part that helps us slow down and make good decisions, not fully online until the mid-20s. And some research shows even all the way up to early 30s. So if we think about the fully formed accelerator and partly formed brake, these are the two parts of the brain that are affected by high-risk behavior and addiction. Now, there's one more thing that you really have to understand about how the brain grows and develops to really understand the context of what risky behavior does to it. And that is this. That first phase of brain development from birth to about puberty, we're actually growing and developing about 200 billion neurons. It's like we get this big chunk of clay. We actually have about 90% of those by the time that we are 6 years old. But at the age of 12, these are all in place and pretty much fully developed. So it's almost like we have this job of sculpting our brain into what's going to be our adult masterpiece by the time we're about 25 years old. And interestingly, it is left over with 100 billion neurons. That's a lot of brain cells that we lost during this stage. And it's not all about risky behavior. This, of course, happens to everyone. It's the pruning process. And so why do we lose 50% of these perfectly good neurons that we just created? What is the point? The point is we need to grow a couple of substances that take up space. So this is a graphic depiction of a neuron. What you see is the cell body right there on the left, a long axon that is covered by a myelin, the myelin sheath. You guys remember that from biology, high school biology. You may have learned about the myelin sheath. But then at the end of this axon, you're going to see these tentacle things that look um, uh, little alien paws reaching out. Those are dendrites, actually my favorite brain structure. But all of this structure needs room, especially myelin and dendrites. So why? Myelin is made up of fat and it helps move the electrical impulse down the cell. And once we hit puberty, it starts to thicken. And the thicker it gets, the faster processing speed we have. So here's a fun fact. We are the fastest thinkers that we ever will be by the time we're 25 years old. If we actually graph processing speed, it would go straight up and peak at the age of 25. And then it kind of levels off and slowly goes downhill from there. And so the older you are, of course, the slower processing speed that you might experience as your brain ages. So we want our kids to peak in processing speed by the age of 25. Now, the next thing that needs room to grow are these beautiful little tentacles at the end that reach out to other cells. Those are called dendrites. And dendrites are literally the hardware of learning. Every time you learn something new or you practice something, you grow more dendrites that reach out to other cells, making long chains of connections for your skills. Let me show you what that actually looks like. So here is a magnified picture of a little baby neuron, a little infant brain cell. So you can see the cell body there at the bottom, the long axon covered in myelin, and then what you see looking like tree roots coming out there at the bottom and on the sides, those are the dendrites. And let me show you what this baby's neurons go through as the child is growing from infant to age 2. So this is such a beautiful slide that really illustrates a skill growing and developing. So you can see the little tiny dendrites that are learning and growing. It's neat to look at this slide because we don't exactly know what skill this is, but we do know that it's the hardware of that skill. So imagine all of these neurons in your brain growing longer and longer and longer over time. Whenever I do this presentation with kids, I hear kids go like, "Ooh, gross, cool," because it literally shows you what a skill looks like in your brain. Now, by the time you are 25 years old, every neuron in your brain will be connected to 10,000 other neurons. Now, all those neurons have to fit inside of your skull. And so what happens is they will squish down in there, and that is what makes all of those funky wrinkles and grooves in your brain, as you can see here. What is neat to know is that infants actually have a much smoother brain. We get these wrinkles as we grow our skills. So we don't want to Botox any of these wrinkles, right, guys? We want a really wrinkly brain because if we do, that means we have a lot of networks of neurons that are in there that have grown and squished down. Now, when you see this beautiful study that followed kids over time as their brain was developing, you'll notice that the color grows darker in the front, where the prefrontal cortex is. So the darker the color, the less gray matter and the more white matter. So the gray matter is literally those cells that I showed you a little bit before. They look on a slide gray or dark. And we're getting rid of those. We're literally pruning away cells, making more and more dendrites that on a scan look really kind of whitish. So those thickening processes are happening in our prefrontal cortex. So if you look at brain age 12, you can see that we're at about 10 to 15% of our frontal lobe development. And if you guys have a middle schooler, you know what that is like. Actually, seventh grade is my favorite like grade to work with because they're not totally too cool for school, but they're just starting to argue. It's kind of annoying for parents because they've got about 10–15% of their abstract reasoning. And then, of course, their limbic system is fully developed. So they start arguing really irrationally, but they only have about 10–15% of their empathy, which actually helps them understand how annoying it is. And so this is a really normal part of development. When my clients ask me, "Oh my God, why is my middle schooler starting to argue so much?" Then I explain the brain and validate that this is really a good sign. If we don't see a lot of arguing or delayed arguing, something's probably going on there. This is actually a really good indicator of normal development. By the time we're 16, you can see we've got about 45–50% of our prefrontal cortex that's grown, our adult brain. And then terrifyingly, we give them a license to drive with half a brain. And this is neuroscientifically why your insurance rates are so high for the first couple years of drive, right? Right. So like seatbelt that in and know it's going to be expensive. By the time we are 20, we've got 80%. Which is wild because a lot of us are like, okay, I'm done parenting, I'm gonna launch, but then we get that terrified phone call from them. They don't know what to do, and we have to kick back in with some parenting because we have a whole fifth of brain development to go between age 20 and 25. Okay, now we know what's growing and developing, those dendrites, those myelin. Remember that dendrites are the hardware of learning, and they actually are really, really flexible. So when you think about neuroplasticity, I want you to think about those dendrites because those can grow and flex depending upon what skills you're using. But remember, processing speed and your flexibility, your neuroplasticity, those peak at the age of 25. And then they level out and slowly downhill from there. That's why learning and thinking become harder as we age. So we got to protect this area of development, especially because our prefrontal cortex is the CEO of our brain and body, which is one of the reasons why the skills that it does have been called executive functioning skills. Now, this is kind of a buzzword, which makes me very excited. I've got a lot of here in Houston. I see a lot of different coaches that are going back to school and learning about the brain and becoming executive functioning skill coaches, which is wonderful because these skills are so critically important to running our brain and body. Now, I'm going to show you the next slide, which describes all of the executive functioning skills for our prefrontal cortex. And I want to encourage you to laminate this. Print it off and laminate it and have it in your office. If you are a parent, I want you to memorize these skills. And if you work with kids, I want you to use this to help assess a kid's skills. So as a therapist who works with teenagers, this is how I use it. I ask kids, okay, let's rate yourself on a scale. Oh, definitely. Tyler will send that out to everybody. As a teenager, rate yourself on a scale of 1 to 10. Which one of these are you amazing at, and which one of these do you suck at? And then what we do is we take the bottom 3 or 4 and we work that into a treatment plan and help them imagine themselves in the office doing those activities. Because here's another fun fact. You actually grow dendrites in your brain when you just imagine yourself practicing a skill. You don't actually need to get up and do it. When you imagine or see someone or imagine yourself doing something, you literally are bolstering your learning right then. And I also love it when kids don't know these definitions, because then you can describe somebody doing it and they're watching in their mind somebody doing one of these skills, and that actually grows more dendrites as well. Okay, so What you need to know about these two lists is the one on the left. The scientists call those lower level executive functioning skills. And these are the ones that you need to get up in the morning, get out the door, right? Remembering your lunch. And then on the right-hand side, we've got the ones that actually start to come online during that second stage of brain development. Now, every kid's different and there's a lot of overlap, but these are the basic outline of when they start to develop. Now, the ones on the right, these are really important skills. Scientists call them higher level executive functioning skills because these are the ones that you need to get up and out of your parents' house, right? Becoming fully self-supporting adults. Now, what is the last thing to know about the brain is the most important. All of these executive functioning skills grow based upon the brain's rule. The brain's rule is use it or lose it. So let me go back here for a second so we can really highlight this. Your brain decides which skills are being used the most, and that's how it decides to grow dendrites to make more connections for those skills. The skills the brain is not using, those are the ones that get pruned away in that pruning process. Why is this critical? Think about it. If a parent does all their kids' problem solving and decision making for them, that kiddo is not going to grow long networks of neurons for problem solving and decision making. But they will grow long networks of neurons for dependency on the parent to do all the problem solving and decision making. And with those networks in the brain, they're going to seek out people as they grow to be dependent upon. So this is why the use it or lose it rule is so important to teach kids. So we're going to teach them the accelerator, the brake, the brain's rule, and all of their skills. We want to make sure that they use them. Okay, so I do a lot of what I call brain-based parenting training. And what that looks like is basically having parents memorize these skills. If you can memorize these, and there's not tons of them, this is why I want you to laminate this and put it someplace, memorize them, and then in your daily language, if you are working with kids in any capacity, you can use this on a daily basis to praise kids for doing these skills. Okay, but here's a caveat. You can't sound like a therapist. You can't say, nice task initiation, Johnny, right? Your kids are going to be like, who are you? So use your own hip, slick, and cool language. It might sound like something like, dude, you took out the trash. I didn't even have to remind you. Yes, nice. Wow, I loved how you organized that. Show me how you did it. You got off the video game in like 10 seconds less than you did last time. That was really good flexing. You're flexibly thinking and moving to a different task. Wow, you paid attention to the most important thing. Or tell me what the most important thing to pay attention to right now is. That's selective attention. Oh my God, those were amazing critical thinking skills. How did you figure that out? Good decision. Wow, last week, you did not regulate very well, but this week you like totally tolerated the frustration. I need you to show me a little bit more empathy today, kid. Or I loved how you showed your little sister empathy. You really understood what she was thinking and feeling. This is brain-based praise. Now, what we know is that when we praise a behavior, that behavior goes up. But another interesting fact is that in that first phase of brain development is when we see most parental praise. Ironically, once kids move into that second phase of brain development, parental praise goes way down. We start lecturing and arguing more instead of praising kids. So this actually gives us a new focus as a caregiver of a kiddo is, wait a second. I can't just be watching for them to screw up all the time because I'm scared that they're going to hurt themselves. I need to focus on what they're doing well. And then if they're having problems in any area here, then you can actually use this to help create a kind of treatment plan for how to increase these skills at home and in school and in different areas. Okay, Now, the number one predictor of adult success is in this slide. So I want you guys to take a guess and put it in the chat. Which one of these executive functioning skills is the number one predictor of adult success? And I'll give you a hint. It's in the right-hand column. Okay, I'm seeing emotion regulation, decision making. Ooh, 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 wait, Rebecca. Rebecca, it looks like you were the first one to get it. I think, oh, I lost it. So many people. Thank you guys for playing. No, I think it was Chris. First one to say impulse control. Ding, ding, ding. That's it. So think about it. You can be really, really intelligent, high IQ, low impulse control. You're going to struggle. You can make a lot of money, but if you don't have good impulse control, you may squander that, right? So impulse control, most important. And if you want some more information on this, I highly recommend that you read the book, The Marshmallow Test, a really great study out of Stanford that was replicated many, many times that proves this point. But impulse control is something that has to be practiced. You got to use that or you might lose it. And we all know an adult out there who has poor impulse control who needs to practice that more. Okay, number one predictor. Now, let's talk about the two things that actually help facilitate the growth of these things. The number one way that kids grow executive functioning skills, anybody out there know? The number one way that kids build skills. Let's see. Oh, yeah, the marshmallow test. Thank you very much, Tyler. Reading is a good guess. Practicing the skills is, but oh, there we go. Play. Brittany, I think you were the first person to say play. And it's actually free play, which is different from adult directed play. When adults get involved, we screw things up for kids because if we can just let them play, they actually, like, Ricky, remember when we were kids and we played, like, I would play family. I would assign somebody to be the mom and be the dad. I would even argue like my parents argued with whoever, and we would take care of the baby and we would solve problems and make, these are all things that build executive functioning skills naturally for kids. Now, we see a decrease, unfortunately, in free play in our world today, which is kind of terrifying because when they don't get to do those things, then the natural acquisition of these skills is stunted. So let's see. Okay, Chelsea says kids don't play anymore outside. There's a great book called The Anxious Generation, exactly, about how kids play on their phones more often. And in The Anxious Generation, Jonathan Haidt talks about 2012. Year 2012 was the year when the majority of kids had smartphones, and we see kids going out less and less and less. As a matter of fact, many years ago, I worked with a 14-year-old, really handsome young man, smart, intelligent, but he had such anxiety. And when we were assessing him, I asked him, do you have a boyfriend or girlfriend? Like, what's your relationships like? And he looked at me and he was like, Doc, fluids, gross. I've got Pornhub and DoorDash. I never need to leave my room. Ah, terrifying. But since then, and I started working with him when he was about 14 and he's about to graduate from high school. Since then, I've heard that from a lot of young people who feel like there is no reason to go out. Anxiety is too painful. I'm just going to stay home and hack the world by being online all the time. But as you know, anxiety management is right here on your screen, right? Emotion regulation, impulse control, abstract reasoning, resiliency. You got to go out in the world and experience all those things to grow long networks of skills. So it's pretty terrifying. Michelle says lack of imagination relates directly to lack of free play. It absolutely does. Okay. Now, there's one more thing I want to say, and then we're going to move on from this slide, I promise, but it's such an important slide. The second most important way that kids grow these executive functioning skills, most people don't ever guess this, so I'm just going to give it to you. Chores. Doing chores builds executive functioning skills. And so here's what we want. We want, like, if you've ever done an activity and a kid came up to you and said, oh, that was my job. That is the kind of ownership, right, that we want kids to have. But as you know, if you don't start them young, assigning a chore later creates a power struggle and, angry feelings. And so here's what the mantra should be. If they can, they should. If they can do the dishes, they should. If they can make their lunch, they should. If they could do their laundry, they should. We want them to have ownership like that. As a matter of fact, kids who get assigned chores younger grow up with more self-efficacy and higher self-esteem, and of course, more skills. And so Brittany says that's why toddlers want to help you and do what you do. Exactly. And so just to have to keep them as they grow up. We want to let them do those. Yeah. I actually had to arm wrestle with one of my parents that I was coaching once when I told her to let her kiddo do his laundry. And she said, no, that's my job. And she would not let go of it. And I finally got her to admit the reason she did it is because she wanted him to come visit when he left home. And I'm like, okay, this is not like, we don't want to be used as a servant for our kids. We want to develop a relationship where they like us enough, right, to come back and visit us, right? Not some enabling kind of codependency, right? So, okay. So now you guys get the accelerator, the brake, the brain's rule, and what this beautiful brain is growing and developing. So we want to make sure that our mantra is dendrites, 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 right? We want, if they can, they should. Okay, now we're going to move to talk about the not the fun stuff, right? The harder stuff, the high risk behavior and the effects on the brain. Now, when we talk about this, I use the word addiction a lot, but please, you guys got to know that it is a continuum, and I know it's a continuum. We go from experimentation to misuse to abuse before we ever meet the full criteria or even a few criteria of full-on dependence. So please know when I use the word addiction that I am referring to that whole entire continuum. But to really understand how it affects the brain and brain development, we need to understand how it affects both the accelerator and the brakes and teach this to kids. So I want you guys to know that this information is available in my free online prevention program, knowyourneuro.org. And so Tyler, if you wouldn't mind putting that link into the chat. It is a free program that has videos for kindergartners all the way up through 12th grade. And if you go to the topics, you'll see 2 videos on the brain, which illustrate in a very short attention span period of time what I'm about to discuss with you guys. So you guys are, of course, getting the adult long version. So we're going to first start with the effects on the limbic system, our beautiful accelerator here that you see in 3D blue. Now, remember, this is fully mature by the time we hit puberty, and it's also not a thinker. It is a reactor. It goes into fight, flight, freeze, or moves you forward to engage you in the environment. So we're going to really focus on the pleasurable experiences of it and how that gets the limbic system hooked. And in order to do that, we need to think about, okay, what are the 4 things in the whole wide world that make us happy? Here you go, right there on this screen. These are the 4 things that actually allow us to feel fun, happy feelings. When we are in pain, our body increases endorphins and enkephalins, and that soothes us. When we need to regulate our mood or our muscles, our brain and body produce serotonin. When we fall in love with somebody who is trustworthy and consistent, and we create an authentic companionship, our brain and body produce oxytocin to bond us with that person. And of course, when we are learning something, our brain gives us a shot of dopamine. And so dopamine is many times, I think, misunderstood. Of course, dopamine in and of itself is not addictive, but too much dopamine makes structural changes to the brain that then causes addiction. But it's not the causer of addiction. Dopamine is this amazing neurotransmitter that our body makes to signal when we're doing something good for survival. Now, remember, it goes up and down all day long because it's supposed to. So, dopamine gives us these calm, happy feelings when our brain signals salience. So, the word salience is important. Salience means, hey, something is good for us. It's important. It stands out as something that we want to move toward. And so, the best way to see how dopamine travels in the brain is to understand that it starts in this beautiful accelerator, the limbic system, and then there are these long, spindly dendrites with little receptor sites on them that move into the prefrontal cortex to also carry dopamine there. Now, so what we're doing is learning. The limbic system is like, whoo, whatever this is that we just did was good for our survival. So we're going to make and synthesize and express dopamine. We're going to memorize that. And then we're going to send a signal to the prefrontal cortex that says, wow, you should attach to this because whatever it is, it's like really good for your survival. So we should have like loving feelings toward it. So we want to go toward it. Then it sends a signal back that says, check, roger that, we've got that memorized. Let me give you a real life example. Check out this beautiful picture of kiddo and mom connecting. What they did was took an x-ray and then they superimposed on the brain where the activity is. And so if you think about this little baby, mom or dad is showing up and the limbic system is like, wow, whenever she's here, I get fed, I get warm, I get clean, I get snuggled. She's really good for my survival. So I'm going to increase dopamine and memorize this. Oh, wait, but there's more. I'm going to send a signal to my little teeny tiny frontal lobe that says, attach to her. She is good for survival. And then the signal comes back and we get like a registration. Okay, memorize this. Now, in the future, whenever I see her, think of her, smell her, I'll get an increase in dopamine even before she comes in the room. And then when she's here, a big increase in dopamine because she's good for my survival. This is an illustration of the most important thing that our little humans are supposed to do the first 2 to 3 years of life is attach to caregivers. Okay, I'm going to look over here. Oh, thanks, Tyler, for putting the website in. And Janae says sharing this in case someone hasn't seen it. CTA for a shared strategy for 0 through 25 thriving. You can sign up. Okay, thank you very much. I appreciate that. All right, so we've seen what this beautiful reward pathway does in the brain. When dopamine increases, it's basically just telling us go for it or stay away, depending upon what we need to do to survive. Now, this is the exact same reward pathway that gets hooked by addiction. So let's talk about what that looks like. When we release dopamine, we release it up to a point. And that point is called our hedonic or pleasure threshold. And basically, in plain English, what that means is we're storing dopamine, and then when we release it, we can only release X amount up to a point. So here's a great example. Think about how you feel when you haven't eaten. Let's say you missed breakfast, which is what happened to me, and then I forgot my lunch. This is actually literally going to happen to me today because I wanted to get here and get this PowerPoint up. So I forgot my lunch at home, and so by about 2 o'clock, when my ride is going to come pick me up, I'm going to be pretty hangry. My dopamine levels have plummeted, and if I have to wait till 7, 8 o'clock at night, you guys know, like I don't know about you, but it affects my hearing. Like my husband sounds like the Peanuts teacher, wah, 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 wah. Like I can't hear very well when I'm hungry. I can't focus very well because that roller coaster of dopamine has dipped. It is really low. It's basically my limbic system saying, hey, you need to go do something good for my survival. And until you do, I'm going to make you feel really uncomfortable. But then when you eat, you get this beautiful 100% increase in dopamine. Your limbic system said, wow, you just did something so good for my survival. Here's your reward. Feel calm and happy. We'll do it all again in like 4 or 5 hours. Just your body's feedback loop. When we engage in sexual behavior, we get a dopamine increase of 150%. Why do we get more dopamine for this activity? Yeah, you guessed it. It's about survival of our species. This is not only really good for us, it's really good for our species. And if you think about it, like those two bar graphs right there, like that's a great date night, right? Like that is what humans do, right? So think about all the things out there that might increase dopamine levels. Natural dopamine comes from smiling, comes from eye contact. So let me just say thank you to all those amazing folks out there that kept your videos on. I can see your faces. I can see you shaking your head. It's like great feedback. Oh, thank you for the smiles. All of those things are really good natural sources of dopamine because think about it, like back in, caveman days, if I smiled at you and made eye contact, you might like me and let me into your tribe and then I'd survive longer, right? So these are all really good. Exercise is good for a dopamine increase because that's good for our survival. Now, here's some interesting things. There's a lot of toxic things out there that are not good for survival, but increase dopamine. Like, for instance, alcohol. If you have 1 glass of alcohol, you might see a small increase in dopamine. If you have a lot of alcohol, it can increase dopamine levels really high. Cannabis is the same way. You could use a little bit of it and get a little bit of dopamine, but if you keep using it or use a lot of it, you're going to see higher and higher increases in dopamine. Nicotine is absolutely a big culprit here. It increases dopamine by quite a lot, way too much, which is one of the reasons why it's so addictive. Cocaine, if you were to snort a line of cocaine, you'd get a dopamine increase of 350%. If you use the same amount of methamphetamine, you would get a dopamine increase of about 1100%. Heroin will give you another big run for the money, anywhere between 800 and 1300%. And think about fentanyl, 100 times more potent than heroin. Wow, you can see how the brain is getting hijacked here. Now, let's really break this down so we can understand it. Let's, for instance, take cocaine here. So cocaine increases dopamine by 350%. So remember, your limbic system, the accelerator, the reactor, it does math. It's basically saying, hey, when you put this in my body, I get 250% more dopamine than when you put that food stuff in my body. So that must mean that whatever this cocaine stuff is 250% better for my survival than that food stuff. Now, remember, your limbic system is not the thinker. That's your frontal lobe. Your limbic system doesn't know. It just does the math and it gets hooked and believes that now whatever that was is better for survival because dopamine is all about learning. This is the wrong learning. Anything that goes above our hedonic threshold can make structural changes to the brain. So if you think about it, our brain goes up and down with dopamine all day long, just like the roller coaster. This is our normal feedback loop, right? We get hungry, dopamine plummets, we go eat, it goes back up. We get lonely and bored, we go hang out with friends, it goes back up. This is just your feedback loop telling you what you need to stay in homeostatic balance. When we go above our hedonic threshold, 2 structural things happen in the brain. Okay, I'm going to show you 2 videos of simulations. Let's look at the first one. First structural change. We're going to travel deep inside the brain and you're going to see the limbic system pop out at us here. And we're going to look at those neurons that are expressing dopamine across the synapse. There's a long dendrite and the little teeny tiny receptor sites. Now, your brain expresses dopamine, but when you use too much or it'll express all of its dopamine, and then you can't express the same amount of dopamine for a few hours, a few days. So let's say you use too much alcohol, you used up all your dopamine in your system, and now you feel yucky for a few hours or days after. We call that a hangover, but that's literally what is happening inside of your cells. Your body takes time to make more dopamine and store it up again. Now, the good news there is your body will do that. It will heal, it'll make more dopamine, and then you express it again, and it keeps doing that over and over and over again. But that process can be damaged by substances that spike dopamine levels so much higher. Like over and over and over again, your body just can start fatiguing and getting damaged and poop out because of that. And we see that in addicts that have a really big drug issues with like heroin or cocaine or intravenous users. That is where the term burnout came from. They really don't have a zeal or zest for life because their body is so damaged and can't make the same amount of dopamine again. But for other people who have some symptoms of addiction, you have the ability to repair that part of your brain. Now, I'm going to show you a video of the second simulation that you actually can't repair from. So what you're seeing here are those long spindly dendrites that are reaching out from the reward pathway. And when you expose your brain to a lot of dopamine, your brain learns. It grows more dendrites. It literally grows more and more receptor sites. Let me play that for you again. So exposing your brain to a lot of dopamine causes your brain to learn, to grow more structure, to grow more dendrites, and to grow more receptor sites to handle the influx of all of that dopamine coming in. But then you have more structure. So think about it. Okay, I always think about this story. Last year, no, it was actually the year before. I had a young man. He was 27 at the time. He came to me because he'd lost his job at a bank. They drug tested him and he popped positive for cannabis. And so what is very interesting about this is that he never used cannabis and barely used alcohol when he was younger. His parents always said, "You have genetics for this, so you need to not engage in it." And he listened. But his first semester in college was so rough. He was stressed, and his roommate smoked weed and said, "Dude, you should really try this and it'll help you relax." He finally caved in one day. And by the second semester, his spring semester, he literally was smoking 6 times a day. And so he was telling me that the first couple times he did it was so wonderful. He got so relaxed. He felt so much better. But then a few times after that, he noticed he would use the same amount and not feel the same feeling. So of course, guess what he did, right? He used more. Now we all know that that is called a tolerance building. And literally, when you look at this simulation, you can see a very fast simulation of tolerance. You use a little bit, you grow a lot of receptor sites, and then you use a little bit more and you grow more receptor sites. But then the next time you use, you're like, gosh, this doesn't feel the exact same way it did because now you have more receptor sites to fill. And then one day you have one too many receptor sites. And now you have officially crossed the line from misuse, abuse into dependence. And this is when we see the 3 biological symptoms of addiction happening. We see withdrawal, we see tolerance, and we see cravings. So think about withdrawal and cravings. Once all the dopamine goes away, all these extra receptor sites are like, dude, where'd all the dopamine go? And they're just craving, craving, craving. And the withdrawal is really painful because your body needs dopamine for survival. This is really, really uncomfortable. Okay, somebody asked what's the source of this slide. I can actually give you the source. I can email that to you, or you can get it from me. Email me. It was in this really long, amazing documentary on addiction, and they let me borrow this. Maddie says, this is so interesting. It's like the increased receptor sites are physical manifestations of hedonic adaptation. What you just said is scientifically spot on. This is exactly what we're doing. We are adapting. We call that learning, right? But we are adapting and learning from our environment, from what we put in it. But it's not a healthy learning because these toxic substances unfortunately spike dopamine levels way too high. Now, here's something interesting too. Once you have these new structures, you can't unmake them. This is why we have that terrible saying, once an addict, always an addict. But the good news is over time, they will become inactive. They will stop craving and stop withdrawing, and your body then adapts again. It learns, oh, okay, we don't have that source anymore, so we better go back to our normal levels of baseline. So it literally will close those up, and they also can slough off. Because remember the use it or lose it rule. If you don't use these neuronal structures, they can actually literally get pruned away or sloughed away because we grow dendrites for the rest of our lives as adults. There's always room for more pruning and growth. That takes longer, though, as an adult. Okay, so now you understand how the limbic system gets trapped and literally can make structural changes. And remember, that can happen really fast or really slow, depending upon what substance you're using, how old you are, what's going on. So does that explain protracted withdrawal, Cindy? Absolutely, right? So if you think about that, if you're using multiple substances, a lot of times people will switch to food or sex. That keeps the dopamine levels up, right? So the healing doesn't get to happen and withdrawal can become protracted depending upon it. Okay, all right, let's move into talking about genes. Our genes are so cool. I think they are neat. Like this is literally the instructions for our body. I have a gene that says I'm going to have green eyes. It expressed itself once and it was done. But we also have genes that interact with the environment. And so if we're really, really stressed, our genes will kick in and say, oop, make more cortisol so that it can dampen dopamine and we can be a little on edge and get rid of the stressor. If we take in too much sugar, our genes will say, whoop, we better make more insulin to handle all this sugar coming in. This is the cool part about how our genes interact with the world. And if you think about every cell in your body has a little double helix on it, and on that double helix is about 30,000 genes. About 2,200 of them have been linked to substance addiction, mental health problems, and impulse control problems. Now, many years ago, there was a really great company that Dr. Kenneth Blum, a geneticist, started to get tested. And I got my genes tested. Unfortunately, it is no longer operating, sadly. But at that time, I found out I have 1,100 of these. Thank you, Mom and Dad, both sides of my family. So both sides of those families used a lot of substance that increased dopamine. Their bodies were like, woo, they're putting all this dopamine in here. We don't need to make as much. We've got way too much. And so they stopped making the same amount of dopamine and passed those genetic changes on to me. I don't make the same amount of dopamine. Now, here's what is so interesting about genes. Your genes instruct your body to make all of your neurotransmitters, hormones, and peptides. And we can basically predict what's going to be your drug of choice by looking at your genes. Okay, so here is a bunch of neurotransmitters, hormones, and peptides, and of course, their structure. Now, you can see that each one of these does something different to our body. Right? So GABA is a really interesting one to me. My body makes enough GABA. I don't make enough dopamine. But my husband, he doesn't make enough dopamine or GABA. Now, I don't make enough dopamine and I don't make enough serotonin. And so, but my husband, he makes enough serotonin, but not enough dopamine and GABA. So this sets us up to have two different drugs of choices because each substance out there does something different to our body, but they all have in common dopamine. So if you look at cocaine here for a second, okay, cocaine increases dopamine and serotonin. This is why that was my drug of choice because my body does not make the same amount of dopamine or serotonin. And so cocaine was a really good fit for me. My husband doesn't make enough dopamine or GABA, and that is why cannabis was his drug of choice. It is so funny too. I want to go on like really fun active vacations. He wants to go on like really chill vacations. You can see that manifest in our choices for living. So every drug does something a little bit different depending upon your genes. Okay. So we talked about brain development. We talked about the limbic system. We talked about genetics and dopamine. Now we're going to go into how it affects our beautiful frontal lobe. This is a study that was done in out of NIDA, the National Institute on Drug Abuse, on cocaine. And it's a really, really interesting study. It looks at a functional MRI looking from the top of the brain down, and they took pictures of these two gentlemen's brains. Now, the gentleman at the top, they took a picture 1 second apart so we can kind of see over time what happens. Now, this is what our brain looks like completely sober. This is what all of our brains look like right now, right, you guys? Right, you got, okay, there we go. Shaking heads, yeah. Okay, a sober brain has all parts on. You can see the frontal lobe right there at the top in red. Lots of red means that it is the most active, right? So the color indicates activity. And when I say active, this is actually glucose metabolism. So what that means is your brain is burning sugar, the activity, the fuel that actually is what your brain uses for energy. So you can see that the limbic system, you can see it right there inside and behind, it's on, but so is the frontal lobe. So the accelerator and the brakes are on working together. Now, the guy on the bottom, he just used cocaine as a part of this study. And you can see that that beautiful frontal lobe is down regulating. So it's not completely off, even though it looks off, but it's down regulated, which means it's basically moved the electrical activity someplace else into the limbic system, which is still lit up. You can see it back there. Now, it is full of dopamine. It's like, you went out, you killed dinner. I'm good. We don't need to go hunt, right? Like it's interesting. Like when you eat like a sugar dense, high calorie food meal, we affectionately call it the food coma. We're literally intoxicated on sugar dense, high calorie foods. We're drunk on really, really bad food. And our frontal lobe goes down. It doesn't want to do complex problem solving and decision making. It doesn't want to have deep empathic conversations. Like after Thanksgiving meal, you just want to like watch football and chill out, right? Like that's it. So this is what the brain does also when we're scared. When you're really, really scared, your frontal lobe does not need to do that complex processing. So it moves the electrical activity, the glucose, the metabolism into your limbic system so you can fight, flight, freeze, fawn, or freak out, right? Whatever the choices are of your reactor. Now, here is what is absolutely terrifying about this. If you are between the ages of birth and 25 and your frontal lobe is growing, if it is downregulated, it doesn't get to grow like it should. And so we call that hypofrontality. It used to be called arrested development, and then they had that funny show, and it always gets confused with the show. But hypofrontality is the technical term for this. Okay, so there's a couple of, oh, Melissa, how can we stay connected with you? Love this presentation. Oh, I'm so glad. I'll have my information at the end. Maggie said, I figured that there was something in some people's genes that made them not like certain substances, even really addictive substances. I heard Kelly Osbourne didn't like it and thought, but it increases dopamine, your dopamine by 1100%. How could anyone not like that? Well, it's really interesting because if you make the right amount of dopamine, like you don't need it, you don't seek it out. And people are like, ooh, like this is too much. Like they get the salience, excuse me, the salience, they get sated pretty quickly and their brains are like, And so, but people who don't make the same amount of dopamine, their hedonic threshold is lower. And so they actually will get addicted faster and seek it out more and more. Okay, so Jennifer, you said this is the first time that I really understand the genetic risk in a way. Oh, that makes me so, so happy. Okay, go. I'll have to do a whole video on genetic risk for kids and give that to you. So, okay, we had a question in the Q&A earlier that may be good now. Curious if you've seen the research in the past year or showing that the brain is still developing into our 30s. Yes, I have seen that research. But if you look at the percentage, right? Like we are about 80% frontal lobe grown by 18. And then by 25, we're like 99% there. And so we are pretty much peaking, right? You know, by the time we're sliding into mid 20s, even though, yes, it is still finishing up its development. So we really want to protect that younger growth. Okay, back to hypofrontality. If a young person is going to start using substances here at age 12, or what if they start using porn or gambling? Remember, a half-hour viewing of pornography increases dopamine by 350%. You guys remember what drug did that? Yep, cocaine. A hilarious side note, I was giving that presentation to a high school group, and a young boy came up to me afterward and he was like, okay, if porn increases dopamine by 350% for half-hour viewing, what about just 5 minutes of it? Could I just watch for 5 minutes? Of course, our high school students, we always want to hack it. But remember that it can be a process addiction as well as a substance addiction. Anything that can spike dopamine levels too high, except shoes. You guys can have as many shoes as you want. But anything that spikes dopamine levels too high has the potential to be addictive. So let's go back to our 12-year-old who started engaging in substance use. Let's say they use pretty regularly, because just 1 or 2 times is not going to make those structural changes, but regular use will. And then maybe they get to age 20 and they're like, okay, dude, I'm done. I'm stopping. Think about what's happening though. They have arrested development. That beautiful frontal lobe is not going to look like this one. It's going to look more like the ones behind it, depending upon the frequency and intensity of what they used. So this is why prevention is so critical. I wish more people would pay for prevention specialists because it is so critical. I don't know about you guys, but sometimes I feel like addiction for profit is winning and we have our job cut out for us. So this is so critical. Because once we get to the age of 25, let's say that 12-year-old didn't stop using and they kept going until 30, 40, 50 years old, 1 or 2 DUIs or an arrest or a failed marriage. It probably is because they have arrested their executive functioning development and it's just not there. So I give you a few examples. I'm going to go through these quickly because of time. I want you to just see, though, that there's so many different high-risk behavior out there. On this slide, you can see a 15-year-old heavy drinker's brain scan compared to a 15-year-old non-drinker. Now, you notice that our drinker has a lot less activity in the brain, but look at the structure. You remember those long networks of neurons that squash down into your brain? You can see that neuronal development is happening for our non-drinker, but not for our heavy drinker. He's got diffuse arrested development. If we look at cannabis, we can see the same thing on a Dr. Amen brain guy's SPECT scan. This is looking from the bottom through. If all your little dendrites are connecting, you're going to see a nice smooth scan. But these 2 gentlemen have been using cannabis, and these are actually older photos. These were produced when smoking, green leafy bud, was more popular. Now, really, vaping is much more popular, but you can see the areas that have not connected. They're not holes, I promise. They're just areas that are underdeveloped. So you can see the beautiful where the frontal lobe should be. There's large areas of underdevelopment. We see the same thing when we're looking at nicotine. We see a lot less brain activity. You see that those beautiful frontal lobes should be growing and developing, and they're just not. We see the same thing with technology. This is a really interesting study that looked at two groups of high school students. The red dots, if you were to actually connect them all, you would see the brain connectivity of a group of high school students who had a balanced technology life, meaning they did a lot of academic tech screen time. They did a small sliver of recreational screen time, like video games, but they also had a lot of family time and physical activity time. So their brain was being used through all different kinds of activity, which is what we need. We need a variety of activity in our brain and our body. Now, the purple lines show the brain connectivity of a group of high school students who dropped out of high school and spent 12 or more hours a day at an internet cafe. So guess what they're doing? All they're doing is playing video games. So this is a really interesting but terrifying example of the use it or lose it principle. So check it out. Look at the bottom brain. You see those dense area of connections? That's the sensory and the motor cortex. Of course, that's the part of the brain they're using the most. So they have the most networks there. But look at how many connections these guys have into their frontal lobe. One area of connectivity. That's because they're not using that part of the brain. Use it or lose it. If we take a look at another amazing executive functioning skill, oh, by the way, my favorite executive functioning skill is empathy. Now, when you think about empathy, you have to have abstract reasoning to really get empathy. Empathy is not innate, it is learned. Sensitivity is innate. And you see some kids are more sensitive than others, like sensitive with themselves, sensitive to other people. But empathy is an executive functioning skill that is learned. Use it or lose it. Now, what they did is they found a bunch of college students who had never played this game before, and they did a really good randomized control study. Half the people used in the control group did not play the game, and the other half played it. And the game is Call of Duty Modern Warfare, which is really a murder training game. Like, don't call them first-person shooter games. Call them murder training games. That's what they are. And so what they did was they gave them empathy examples. They had to come up with their own empathy response. And you could see in the baseline, look at that beautiful frontal lobe, like it's lighting up. This is where empathy happens, right? We are literally lighting up our frontal lobe by imagining what other people might think and feel and coming up with an empathic answer. And it stays pretty steady for week 1 and week 2 in the control group, but statistically significantly drops for our gamers. Now, here's the cool part of brain studies is you can ask them, like, what's going on in your head? And the young people said, well, I am killing people in this game. I got to dumb down my empathy because I can't have empathy and kill people. You guys, when I read this study, I had chills all over my body. And I was thinking about how young sometimes we send kids into the military off to war, 18 years old, when we have 80% of our frontal lobe. And then we have to dumb this down. And then, of course, when they get home 2 or 3 years later, we expect them to like just turn that right back on. But if they haven't been using it for a while, it may be really difficult to do. So, if we, let me go back just 1 second. These researchers did a really cool thing. They were so, the results were so unexpected. They stopped the study. They had the gamers stop playing and then redo the test after 2 weeks. And everybody went back to the baseline, which is really good news. So like we can reverse this effect, but also think about young people that you know who've been gaming for like decades or years. You may not actually be able to reverse the effect if you don't intervene during this really critical time of brain development. Okay, let me show you a few more. So we're looking from the back of the brain through when somebody who has no eating disorders actually ate sugar. We love sugar. It lights up our brain. And for this abcnews.com special, you can actually find this in the archives. A woman who had been a sugar addict took sugar or ate sugar as a part of this study, and you can see what happened to her brain. Remember, she already was addicted to sugar. And so she already had all those extra receptor sites, and you can see them literally lighting up. You can see the spinal cord right there, and the limbic system from the back is on both sides of the brain. If we turn her brain around, the frontal lobe would be dark, right? Down regulated because she's in a food coma after eating all that sugar. Very interesting. So also think about this here. Think about if we give our kids sugar dense, high calorie food when they're young, might it possibly affect brain development like anything else that would spike dopamine levels too high? And we're seeing the research validate that. Okay. If you look at somebody who compulsively uses porn and compare their nucleus accumbens to somebody who doesn't, you can see the nucleus accumbens is 4 times the size that it should be. This really illustrates how your brain adapts and grows to suit what you're engaging in. This young woman had a panic attack and a brain scan, and you can see she's in absolute fear. Shuts off the frontal lobe. As you can see down there, it should be red. It's really green. The limbic system in red and the occipital lobe in the back. She's desperately looking for a way out of the scan. So think about what our kids are going through today. Lots of anxiety. I always giggle a little bit inside when clients are like, "Oh my God, I have anxiety." And I'm thinking, yes, we all have anxiety. It's like really normal, healthy feeling. If you didn't have anxiety, you wouldn't care, right? Like you wouldn't care about life, right? So having anxiety is actually really a good sign, but it sucks to feel, right? And so learning how to cope with anxiety is great, but our young people are actually experience deficits. They're not going out and tackling anxiety, right? They're avoiding it. So they're growing long networks of neurons for avoiding anxiety instead of learning the coping mechanisms. But here is a beautiful validation for our work, you guys. This is a person on the left who has no depression compared to an adult who has chronic depression. You can see the frontal lobe is downregulated, but look at this beautiful study that this person underwent. 6 to 8 weeks, I can never remember, 6 to 8 weeks of talk therapy plus an antidepressant. So we know that therapy works. Therapy works better when your medication is paired with therapy. But this is just a beautiful validation of our work, right? It shows the frontal lobe turning back on, the whole brain turning back on. It's really, really just wonderful. So Chelsea says, have they studied how therapy can change these neurological effects? Do we know which therapies help the most? Well, what a great time to read your comment on this slide. Literally, this validates that therapy does work. And if you look up common factors theory, you can see there's studies done many years ago that compared every therapy out there. And we now know that there's really no one therapy that's better than another. As a matter of fact, 30 to 40% of how efficacious a therapy is attributed to the relationship that the person has with their therapist, right? And so, we got to be really good at relationship building that turns the frontal lobe on. But I think a really good comprehensive approach I actually wrote another book called Fu Mapping. I do family of origin therapy with clients. I take them through 5 neurodevelopmental stages. We map their cognitive, affective, behavioral, and family system effects from a neuroscience perspective. And then we really figure out what your learning style is, what suits you best as to how to practice growing new neuronal networks. All right, you guys. So we're going to talk about the last couple slides are on relapse prevention. And then if you guys have more questions, feel free to put those in the chat. But when we think about once you're there, like once your brain has become adapted and you meet criteria for dependence, what do we do? This slide really illustrates the breadth of the problem. We're going back to our old cocaine abuser from our NIDA study, and you could see the middle brain right there. He's 10 days sober here. This is terrifying. because look what the frontal lobe is doing. Not much. And you guys know, like, this is why we don't do trauma work in the first few months of therapy, because that can light up the limbic system again and send you into fight or flight. What we want to do is stabilize you. We want to feed you. We want to hydrate you. We want you to get a lot of sleep and rest. And we want you to go to a lot of really good meetings with healthy people so you can get eye contact and lots of smiling and connection as a good dopamine replacement. But then look, here's the cocaine abuser 100 days sober. Wow, 100 days sober. You can see the frontal lobe is just beginning to turn back on. So here's what we know. It takes about 18 months for the brain to return to that normal brain at the top, a year and a half. So let me show you some numbers. You can see that the relapse rate, let's look to 1 year. At 1 year, we're 50%. 50-50 shot of staying sober. Like, these are not great odds, especially that first year of sobriety. Knowing how high relapse rate is, making sure we get you into a long-term treatment. So it looks like this. You might go through a detox. You might go through a PHP, a partial hospitalization. From there, you may go, or you may do like a residential treatment where you're in there for 24 hours. Then it's important to go to a step down. You want to do an IOP where you go every day for 4 or 5 days a week. You want to do that for 6 to 8 weeks, or maybe even double it up, 16 weeks. And then from there, you want to go into an SOP, a supportive outpatient program, where you're stepping down how much structure you have, but you still have a lot of structure. And we want you to do that for as absolutely long as your insurance or a payer will let you, on a sliding scale if you need it. Then you want to continue your individual therapy. And the whole time you're doing all that, you want to go to lots of meetings and get a sponsor and get into recovery. And then you can see, you guys, see the purple line at 18 months. Look at that statistically significant drop. That is when the brain turns back on and you're starting to grow those dendrites again. And then we know that at about 5 years of recovery, your relapse rate drops to about 15%, and then it stays that way for the rest of your recovery because you've made those structural changes to your brain and you cannot unmake them, darn it, no matter how old they are. So this is what it looks like, and we need to be able to support people through this. But as you guys know, how long does insurance last, right? Like, you may get the first 2 weeks. So being able to explain this to the client, I think, is ethical. It's critical to say, here's what you're up against. How can I support you through this? What can we do to create a treatment plan that puts you in this beautiful little hammock and, rocks you into recovery until you can stand on your own 2 feet? All right, you guys. So I believe, I wanted to share a little bit more about me before I finished. So I have researched all of these different high risk, or not my own research, but I've collected everybody else's research, prevention science for the past 80 years. And I put this into my parent guide. It is called the Neuro Whereabouts Guide. I made up a word and Urban Dictionary approved it. So it's officially a word. Neuro Whereabouts is, where is your child's brain? What can it do and what can't it do? And as a parent, what can I do to grow those skills and protect it from these things? My kids that helped me with my internships, I say kids, they're like high school, college age adults. They helped me write the teen version of this, which is actually in a little different order. The parent guide shows you a graph of all the high risk behaviors according to when they show up sequentially, elementary, middle, high school. This is actually by topic and written by young people for young people. They took all the research and updated it for the teen guide in the book. And I just love it because it's literally written for a youth. And then, of course, I want to introduce you to Neuro. He is the superhero of my children's book series, Know Your Neuro, Adventures of a Growing Brain. Book 1, you get to learn about the accelerator and the brake, and then all the books that come after, you get to learn an executive functioning skill for your age group that is developmentally appropriate for you. Like, if you look at some of these topics, aren't you like, man, I wish I'd learned that when I was a little bit younger, right? And so please feel free to look at Amazon. And then the best part is all of this information is free on knowyourneuro.org, which is my nonprofit. The royalties of all the books go to this nonprofit to keep it up and running and giving free prevention for schools all over. I actually just upgraded all the videos to 6 new different languages. There's a gambling page now. I did that over the summer. If you have a special request or a topic that you'd like me to research and create a video all about the brain, let me know. This is kind of like my hobby of doing this stuff. And there's also a really good new sign up on the page where you can put your phone number in it and get curated text messages from me that prompt you on how to have a conversation with your kiddos about these high risk behaviors. So please feel free to do that. No obligation beyond that. All right, so here's me. This is the QR code for all of my books that are on Amazon. And we've got minutes left to talk. Oh, thanks. I'm seeing a lot of good comments here. Wonderful
We do have one
resources.
question.
Oh, you do? Okay, thanks.
Yep, from Dominic. He says, I'm curious about relating AI use for completion of tasks to the use it or lose it rule.
Oh, this is extremely terrifying. Okay. If you use AI to write a term paper for you, you do not get to learn how to write a term paper. Your brain does not grow long networks of neurons for writing that term paper. If you use AI to be creative for you, then you don't grow networks of neurons for creativity. And we're seeing this happening all over. I mean, not to mention the distraction of screens. Every time a child is distracted in class, they lose about 9 minutes of learning. Um, if you want more information on the neuroscience of screens and your kid goes to a school that you might want me to come present at, there's a really great organization called smartfamilies.org that actually pays for schools to have programs like this. And I would come out and speak for your school if your school signs up for a Smart Families program. But it's really terrifying to me to see what happens. I mean, I use AI every single day to help with a lot of different activities that I do, but I try really, really hard to write the sentence first. Because and then ask AI to improve the flow or the grammar. But remember, that means I'm not doing that work myself. So I'm not growing neurons for improving flow and grammar. I'm relying on AI to do that. I have the benefit of a fully formed frontal lobe that hopefully got to heal because I got sober younger. But the terrifying thing is that our kids who are, growing their brain, they're growing their brain for watching skills and not really doing skills. And so I think it's going to have a profound effect. And, one day we may just all choose to plug into the matrix because it'll do the work for us. Not sure. Okay, good. I'm seeing a lot of really good thank yous. Oh, I appreciate it. I'm so glad you like it. This is really, really good stuff. If you want to learn more, please go to knowyourneuro.org. You can use those videos in session. You can use them, you can share them, send them with parents, or send them to a school. Shantae says Johnny's Ambassadors is a great presentation for marijuana. Exactly. Please know I am on the advisory board for Johnny's Ambassadors, and I am a really big fan of the work that she's doing to make sure her son's memory is kept alive and helping others to learn the harms of marijuana. Stanford Reach does a really good a lab with great resources in it too. They have a good cannabis conference every year as well. So lots of high risk behaviors to focus on. So, oh, good. I'm glad. Thank you guys all for these compliments. It's been so wonderful. Any more questions? Ooh. Tyler, I know you're filtering through this too.
I didn't see anything besides somebody asked me if you can access the recording.
Oh,
Yes. So
yeah.
we are obviously recording it and we'll get that uploaded to YouTube and let everybody know
Yay.
um, and get the slides out to people. Wonderful feedback. That's awesome. So please do take that survey so that we know that Crystal's awesome. you know, for our grant, and then we'll bring her back, hopefully maybe in October to talk about gambling, problematic gambling. It always sounds like I'm like for gambling when I just say that. But yeah, if there's no other questions, we can hang out for a minute just to see if anybody has anything. But
Okay, let me see. Janae, it's been so exciting to watch brain science evolve and affirm so many of the theories soft sciences has supported for decades. Absolutely agree. Retired teacher with degrees in psych and human development, working in public health. Oh, we're fighting the good fight here. I feel like I constantly need to provide extra evidence to back up strategies that I advocate for. Oh, word, I feel that. I love teaching, but prevention was always my primary interest. I mostly choose to teach because I knew kids who needed me most would probably be in the schools, even if they never made it to therapy or other places for interventions. I love that experts with reach are getting information out into the world where it belongs. I've kept up on research and studied continuously ever since I left school, but I often don't feel like I'm taken seriously at work. Thank you. Oh, Janae, thank you for that. I feel you, get you. I feel the same way too. And that's why I created Know Your Neuro, really, is that I did my dissertation at a high school here in Houston and created the program. And my research showed that statistically significantly, the behaviors went down every single year. School climate was better. Kids are so interested in learning about the brain. But addiction for profit is freaking powerful. And many parents don't want to let go of their addictions and don't know how to when they feel powerless over things like their screen use and things like that. So I really want to applaud all of you for the work that you do and keep fighting the good fight.
we have one more question, and I am
Oh,
curious about this one too.
okay.
How long does detoxing from sugar take? Is it the same as an illegal drug?
I don't know of a study for that. There might be. I just haven't done the research on that. But just anecdotally, I've worked with many clients who have food addiction. And it's interesting. I've heard dietitians say you can't get addicted to things that sustain you. And I'm like, okay, maybe I can't get addicted to broccoli, but I can sure get addicted to donuts. Like, anything that might spike dopamine above my threshold. Broccoli definitely does not. And so, but what I've seen in my clients is that 2 to 3 days of massive withdrawal and cravings is what they go through after they have a bout of binge eating sugar dense, high calorie foods. But then stabilization for that could be weeks thereafter. However, I'm seeing beautiful results with GLP-1s. Not only do they bind to the receptors in our gut and our intestines to slow down motility, but they also bind to receptor sites in our brain. One of my clients said that it shuts off the food noise. The food noise is just like another way of saying cravings, right? The cravings for it. If you've ever eaten a meal and then craved dessert, this is those receptor sites in your brain that are binding to dopamine and loving the food, but now want a little bit more. I think that makes me my mouth water. I think we all have like one too many receptors in our brain for sugar dense, high calorie foods because of the food industry and how they've increased sugar in our foods, but also, sweeteners and things like that that change our brain chemistry and make us continue to crave more. So, very interesting. So I don't have a study that illustrates that, but just my anecdotal information as a clinician. Ooh, more coming in. Let's see. There's one. Lisa says, how do we help kids get past the anxiety when they refuse to do anything that causes them any kind of stress or fear? This is progressive activation. And, a lot of times, if you think about some of the anxiety management techniques that we use, we do little, teeny tiny steps and we experience the anxiety. And so it's progressing through anxiety stimuli provoking that we need to help them work on. And they're going to need a lot of work with that because I think that many kids today meet the criteria for anxiety disorders just because they haven't developed the skills for normal anxiety yet. Jillian asked, is there a strategy for parents who feel powerless over teen and adult child screen use? especially got out of control as a child during the pandemic? Oh, definitely. I think we, all did. This is unfortunately going backwards. And this is when we have to use behavior modification. And we have to understand what an extinction burst is and how to parent through that. So I actually did a presentation called BMOD that's on Operation Parents archive website if you want to check that out. But it literally is helping parents accept that their child has already developed a problem. And so it's going to take double, maybe triple the time to undevelop it and to create new habits. But it can be done. It's just really harder. Michelle said, best presentation I've seen in a long time. Oh, thank you. That makes me so happy, you guys. Brittany says the food industry is much like the drug industry, adding synthetic and additives that make them more addictive. Absolutely. I mean, it's the game industry, the technology industries. I just lump them all into addiction for profit because that's what they are. And it feels like they're winning, in so many ways, and definitely politically. Like, in 2018, the Supreme Court overturned a law that federally banned sports betting, a really great law. But because many politicians want the states to have the rights, then unfortunately, they have overturned a law that was really beneficial. And now over 36 states in the union have legalized it. And now we have not only addiction rates in youth skyrocketing, but bankruptcy in adults skyrocketing. Okay, enough of that. I know I have completed my time, but
You're amazing.
Tyler,
No, no, no. We're
yeah.
at time, but
Oh, good, good,
I'm
good.
sharing
Okay.
the survey. If you want to scan that QR code, I also put the link in there. Any questions? We'll be doing, obviously certificates. We'll get people recording slides. Clearly, we'll bring Crystal back. Please fill out the survey so that I have the data to say that. But I really appreciate everybody being here today. Thank you, Crystal. Thank you, everybody. Very excied. Yeah. All
Awesome.
right.
Great.
Have a good day,
Thanks, you guys.
everybody.
All right. Bye.